Hello, welcome everyone. Almost ready to start. Maybe we wait a few seconds until all the participants are connected. Okay, let's go. Welcome everyone. I'm Marc from Euresys. I'll be your host for today's Vision Talk. Thank you, Sandrine, for organizing this presentation as usual. And today's talk is about CoaXPress frame grabbers, and we also welcome Paulo, who is our frame grabber product specialist. So we welcome your questions during and after the presentation. The Q&A system of WebEx has changed a little bit recently. So there is an app which is called a Slido, which is used to exchange questions with the participants. So if it is not open yet, please open the Slido Q&A panel and you can type your questions during the presentation. I think that the panel should open automatically for the users. Now, if there is any problem or you really want to type a question and it does not work, then please raise your hand and we will do our best to help. So this is the agenda for today's presentation. We'll cover quite a number of topics. We'll start with a quick overview of our latest Coaxlink cards. Then we will talk about new functions introduced with the latest release of the driver called eGrabber. We will also present an interesting use case of CustomLogic. We will then talk about CoaXPress-over-Fiber, and we will conclude with a quick presentation of our frame grabber roadmap covering the rest of the year. So, Paulo, it's up to you with first a very quick overview of our latest Coaxlink cards.
Okay, thank you, Marc. Hi, everyone. I'm Paulo POSSA, frame grabber product specialist at Euresys. As Marc mentioned, let's start with a quick look on our Coaxlink series of frame grabbers. The Coaxlink series of it's a family of CoaXPress frame grabbers targeting high-performance machine vision applications. With this family, we cover a wide range of CoaXPress configurations, going from 6x6 with 4 to 8 connectors, 6x12 with 1, 2, and 4 connectors, and also CoaXPress-over-Fiber, which allow us to use fiber cables to transfer images from camera to frame grabber. A new member of the Coaxlink family is the Coaxlink Quad 6x12 DF, where DF stands for data forwarding. This frame grabber, it's a specialized frame grabber with two main functions. The first one is to receive images through 4 6x12 input connectors and transfer these images to the host PC via its PCI Express interface. The second function is to forward these images without any delay to the next DF board via its 4 6x12 output connectors. This allows us to create a daisy chain topology where the same image coming from one camera is distributed to multiple PCs. The objective of this configuration is to scale up the processing power of an inspection system. And this is especially important for Quad 6x12 applications where the camera throughput can reach up to 5 gigabytes per second. Then we have the new Coaxlink Quad 6x12 3D LLE. This is also a highly specialized frame grabber with onboard laser line extraction for 3D profiling. The idea behind this frame grabber is a technique called laser line triangulation, where we project a laser line over an object. As a result, we will see that the laser line describes the profile of this object. The frame grabber then detects the laser line and computes its relative position in the image. By taking successive images from the object being scanned, we can then recreate what we call a depth map, where the pixels represent a position in a 3D space. The advantage of this approach is that we process the laser line directly in the frame grabber's FPGA. And with this, we can provide the depth maps as fast as the camera can provide images. As this is a quad 6p12 frame grabber, the camera can provide up to 5 gigabytes per second of images. So now let's take a look on some of the new general features of the Coaxlink frame grabbers. The first one is called multiple cycle timings. This feature allows to create triggered sequences with different timings for camera exposure and strobe. It means that you can have trigger sequences where each trigger is generated with independent exposure time and strobe duration. At the same time, we can also use the strobes from a sequence to activate different light sources in a system. In this example, we created a sequence with 5 different trigger timings, where each trigger has its own exposure time and strobe duration. As a result, each acquired image in the sequence will have a different response to the light. We can see here in the bottom. DMA, de-Interlacing, it's another interesting new feature. It can be used for line scan applications where each line is exposed alternating 2 different light sources. The image coming from the camera will have this striped aspect. To process this kind of image, the application will need to proceed memory copies in the host PC, which takes time and use CPU resources. To avoid that, we introduced this new feature where the de-Interlacing is done at the DMA level. It means there is no memory copy involved and no CPU processing. The result is that your application will directly receive 2 buffers, 1 for each light source. This is another example that uses these new features to create a planar RGB image by using a single monoline scan camera and 3 different light sources, 1 for each color. It follows the same idea from the previous example, but now we are de-Interlacing the image into 3 different buffers, 1 for each color. Back to you, Marc.
Thank you, Paulo. That's interesting. Trying to next slide. Okay, I'd like to further demonstrate that DMA, de-Interlacing function that you are talking about. So what you see here is a demonstration that was on display at the Automate Show in Detroit last month on our booth. So that's the setup. It's using line scan cameras from ChromaSense and Coaxlink Quad CXP12 frame grabber. in a demonstration that shows image acquisition for battery foil inspection application. So you can see barely the battery foil here on the drum. And then you can see that it's using two lights for simultaneous interleaved dark field and bright field illumination. So the bright field illumination is vertical, and I'll try to show you on the image. If you see my pen pointer, that's the bright field light, which is almost parallel to the camera axis. And then we have the dark field illumination on the left with a much lower angle. And it's super interesting to use bright field and dark field illumination to detect different kinds of defects on the surface of the object. So it's not possible to see in the video, but these two lights are not constantly on. They are being switched on and off alternately in synchronization with the camera. So the camera acquires one line with the dark field lighting, and then one line with the bright field lighting, and so on. And this is the result. So you see the setup again on the image on the right, and then you see the images that are acquired on the left. So during the acquisition, it is the job of the Coaxlink card to separate these lines coming from the camera and to store them into two separate images in host memory. So we end up on the top of the image here with the bright field illuminated image, and at the bottom of the window, the dark field illuminated image. And this is all done by the frame grabber during the acquisition, using DMA, what we call DMA de-Interlacing or DMA de-Interleaving. And that's a function which does not take any CPU, so it's completely free to execute during the acquisition. So this is that was actually a good example of what that new feature that we have added in the one of the latest version of eGrabber. Before we move on, I see that we have received a couple of questions. So it will be for you, Paulo. Question number one, are these functions available with any eGrabber driver?
Okay, so no, these functions, so eGrabber drivers and tools are constantly evolving with new features and improvements. The best way to keep up with these new features is to check the eGrabber release notes that are published every new release.
Thank you. Then next question, with DMA, the images are offset by one line at least. Is this correct?
Yes.
I don't know if we mean, yeah, okay.
Yeah, so the DMA will automatically create the descriptors pointing to the right positions of the end buffer, so the GentL buffer, and each line will be right in the right pointer of this buffer. So this is how the DMA will proceed the interlacing.
Okay, thank you. Next question, where can we find the documentation of these functions?
So we have extensive online documentation covering all aspects of our products, including eGrabber and Coaxlink frame grabbers and all the other products. You can find this online documentation at documentation.euresys.com.
Okay, thank you, Paulo. I see another question here. Okay, am I somehow limited by the number of DMA buffers created? For example, maximum 3 for RGB, or it's also possible to have 5 DMA buffers, for example?
Yes, sure.
So yes, it's possible.
Sorry?
Yeah, you mean yes, it is possible to have more than 3?
Yes, it's possible to have more than 3 buffers. Yeah.
And is it always alternatively? So this is will be buffer 1235, 1235, 1235. If you have a complex illumination, sorry, I'll ask a difficult question.
Yeah, no, but not really. We have a very flexible DMA programming. It will be even more flexible in the future, and we have many applications with very specific DMA program that can do any kind of
reordering.
Yeah, the buffer arrangement. We can do very complex solutions with this DMA programming.
Okay, thank you, Paulo. Anyway, it's up to you again for the rest of the presentation.
Okay, thank you, Marc. So now some general onboard features of the Coaxlink frame grabbers. One important feature for machine vision applications is the digital inputs and outputs available on the frame grabber to interface with the machine itself. Our frame grabbers have a very rich set of inputs and outputs that are compatible with a wide range of sensors and motion encoders. They are accessible via 2 internal connectors and 1 external connector. We have also a I/O extension to include additional I/O modules and a C2C link interface for camera synchronization between different boards. Along with the I/Os, we provide an extensive camera illumination control functions for both area scan and line scan. In this toolbox, we have embedded quadrature decoders, delay tools, divider tools, and rate converters. As I mentioned before, C2C link can synchronize cameras connected to different boards. These boards can be synchronized inside of a PC, a single PC, by simply adding a ribbon cable to connect all the boards, or even in different PCs by using an accessory called inter-PC C2C link adapter. So we can synchronize cameras connected to different boards inside of a single PC or in boards that are inside of different PCs. We also offer a set of onboard pixel processing functions to offload these processing tasks from the camera and host. In this set of onboard functions, you can find light field correction, Bayer decoding, pixel binding, etc. And if you need additional onboard pixel processings, there is also CustomLogic. CustomLogic allow FPGA designers to include their own image processing modules inside of the frame grabber. The CustomLogic framework provides the whole acquisition infrastructure, including CoaXPress front-end, memory controller, DMA engine, and driver. With this framework, users can concentrate their efforts to create their own image processing accelerators without expending time with image acquisition and camera control. With CustomLogic, you can have access to more than 70% of the FPGA resources, and it's currently available on 3 boards: the Octo, Coaxlink Octo board, Coaxlink Quad 6P12, and Coaxlink QSFP+.
Thank you, Paulo. That's interesting, very interesting. Next slide. I'd like to further elaborate on this with a real application case. We have recently published an article that describes a really interesting project that uses CustomLogic and our Coaxlink Quad CXP12. So the project involved a tokamak, and I didn't know what it was. A tokamak is a fusion reactor built to study nuclear fusion, the kind of a reaction that will be used for future power plants. A group of universities and laboratories has used the Coaxlink card to reduce the latency of what they call the plasma control loop. So this is an example, a block diagram of the system here. So we see that the customer has implemented image analysis, including some deep learning with signal processing, up to communication of the results on serial lines, all using CustomLogic in the Coaxlink FPGA without going through the host PC. The schematic of the card is here in the middle. The camera is on the left. It delivers images to the frame grabber. Inside the FPGA, they have programmed image analysis. In this case, it even involves some convolution neural network, so deep learning, and processing of the results, including transfer of the results. So this is a really interesting application case. I confess that this is not the primary market for Euresys. We sell more cards for inspection and the quality control, but this is nevertheless a very, very good example because it shows what can be done with CustomLogic, and it also shows that CustomLogic can be used to improve the performance of the image processing loop. So in this implementation, they have reached the total latency of 17.6 microseconds, which is very, very short. So we are talking about millions of seconds here. And this latency is the time between the trigger sent to the camera for image acquisition and what they call the control out, which is the sending of the result on the serial line. This is achieved using a fast camera. Of course, the camera must be fast enough. So here we have a camera frame rate of 120,000 frames per second. So very interesting application here. One of the questions we received is, can you share the link to the paper with us? And so, yes, done. Sandrine, can everyone see the link or only the person who asked the question? We will share the link with
everyone is seeing it. Yeah.
Okay. Thank you very much. Another question that I'd like to ask here is how to get CustomLogic and what is the cost of CustomLogic now?
Okay, so to have access to CustomLogic, you have to contact our sales department. Our sales department will analyze if CustomLogic can help you in your application, and then they will give you access to the CustomLogic package. In terms of cost, so CustomLogic doesn't require any extra license, additional license to use with our frame grabbers. So there is no extra cost involved with CustomLogic.
Okay, thank you, Paulo. Back to you for the next topic.
Okay. So now let's take a quick look at the Coaxlink software features. We have a whole software framework that it's just distributed with our products, starting with our eGrabber driver, that has a modern and user-friendly object-based API. It is full compliant with GenICam, supported on Windows, Linux, and macOS for both ARM and x86 architectures. The API is compatible with C++, C#, and Python. It's supported by third-party image processing libraries. And it also supports direct DMA to GPU for applications that require extra power, processing power. Then we have eGrabber Studio, that it's a very powerful image acquisition software. eGrabber Recorder, that it's a video recording library. And eGrabber PlayLink, that can play the eGrabber recorder containers as a virtual frame grabber with camera. And we have also Memento, that it's our event logging tool, very appreciated by our customers. Now I want to talk a bit more about CoaXPress-over-Fiber and our products based on this technology. So CoaXPress-over-Fiber, it's an extension of the CoaXPress standard to support fiber optics to transport images from camera to frame grabber. More than an extension, it benefits from low-cost standard Ethernet components and their free evolution to higher speeds. Also has an improved data integrity with forward error correction. The use of fiber optics has other advantages of copper cables. They have higher and almost unlimited bandwidth, virtually unlimited distances, reaching up to 40 kilometers with standard components. It's immune to electromagnetic interference and reduce cable congestion. This picture shows the clear difference between two sets of equivalent cables with 50 meters. So just to be clear, in the left side, we have 4 cables, coaxial cables with 50 meters each. And in the right side, we have an equivalent cable on fiber. Inside of this cable, we have 4 pairs of fiber. So we have 4 channels equivalent to 4 cables in coaxial cables. And we can see the clear difference in terms of volume, weight, and diameter. So this is the Coaxlink QSFP Plus frame grabber. It has equivalent bandwidth and features as the Coaxlink Quad 6P12. But instead of using coaxial cables, it uses fiber cables to transport images. I have here to show you a board, so Coaxlink QSFP Plus board. So instead of having the HD BNC to connect coaxial cables, we have a QSFP Plus connector. And to connect the fiber here, we can use these optical QSFP Plus modules. And it's quite easy. It's just a click the module inside of the QSFP Plus cage. And it has a very strong mechanical fix. It's very strong, the mechanical fixation, let's say. And to release the module, you just pull the small thing there, and it releases the module. So in terms of cables, we can use this kind of cable. It's an assembled cable, so the optical transceivers are embedded with the embedded cable. The fiber cable, it's fixed to the module transceivers. This is a simple way to connect the Coaxlink QSFP Plus frame grabber. And you can have different cable lengths with these modules. Then we have separate optical modules. This one, it's for 40 kilometers. So this module can do up to 40 kilometers of cable. This one specifically, they use single mode fiber. That it's a single pair of fibers with a duplex LC connector. And this cable can have up to 40 kilometers. Then we have the same modules, but with a different kind of cable, fiber cable. This is a multi-pair fiber cable with 4 or 8 pairs of fiber inside. And we use MPO and MTP optical connectors. This is usually available in multi-mode fiber and can reach up to 150 meters with standard optical transceiver modules. But we have already in the market modules with extended cable reach that can go up to 400 meters. Okay. So then we have the Coaxlink 6P12 to QSFP Plus converter. As the name indicates, it converts a quad 6P12 interface into a CoaXPress-over-Fiber QSFP Plus interface. With this product, you can take the advantage of both worlds. In the quad 6P12 side, you can interface with a large number of CoaXPress cameras available in the market. And at the QSFP side, you can use very long fiber cables to connect to the Coaxlink QSFP Plus frame grabber. So still in the Coaxpress-over-Fiber context, this is our brand new product that will be released in the next months, the Coaxlink QSFP28. The Coaxlink QSFP28, it's a 100G frame grabber. It can support up to 12.5 gigabytes per second of camera bandwidth. This is 2.5 times more bandwidth than a Coaxlink QSFP Plus. It has a PCI Express Gen 4x8 and 8 gigabytes of onboard memory for frame buffering. Just in terms to have a comparison, it supports the same bandwidth as 10 6P12 connections, 20 6P6 connections, and more than 14 CameraLink full boards in a single PCI Express slot. The first units of the Coaxlink QSFP28 are already available for early evaluations. There is already a number of ongoing evaluations by customers, and its official launch is planned for Q4 2025. So what next after the Coaxlink QSFP28? So now we are working on a new board called the Coaxlink Octo 6P12 frame grabber. It supports 10 gigabytes per second of camera bandwidth with its 8 6P12 connectors. It is equipped with PCI Express Gen 4x8 and has 8 gigabytes of onboard memory for frame buffering. With 8 6P12 connectors, we can create very compact and cost-effective systems. With a single board, we can support up to 8 6P12 cameras with single connectors. And also we can support several other combinations like 5 cameras, where one camera has 4 6P12 connectors and the other 4 cameras have a single 6P12 connector. For this board, the plan is to have the first evaluations by the end of 2025 and the official launch in 2026. Okay, so that's all from my side. Back to you, Marc.
Thank you, Paulo. I'm checking if there is any question coming in. I see, in addition to CoaXPress-over-Fiber, RDMA is also on the rise. What advantages does CoaXPress-over-Fiber offer, and where do you see future developments? And do you plan to work on an RDMA-based frame grabber? So by RDMA here, I think that we mean GigiVision 3.0.
Okay, so yes. So the advantages of CoaXPress-over-Fiber, it's that we can use CoaXPress, that it's a very stable and precise interface for camera interface with very accurate triggering, very robust transport layer, very low latency. And so it's really the same CoaXPress, same advantages of CoaXPress interface, but using fiber. For a frame grabber for RDMA, for Gigi RDMA, this is something that we are studying for the moment.
Okay, thank you. Another question, 2 questions. Going back, I understood that it's possible to do image processing in the frame grabber like binning. What are the differences to do it in the camera versus in the frame grabber? What are the pros and cons?
The advantage of doing the binding, the pixel binding inside of the frame grabber is that you remove all the heating caused by this extra processing inside of the camera to the frame grabber. So the frame grabber itself doesn't have any problem with heating because we have heat sink that can draw all the heating from the FPGA. But inside of the camera, every extra processing that you do in the camera will generate heating inside of the camera. And we know that the sensors are very sensitive to heating. So ideally, the camera should not spend energy doing image processing, a lot of image processing, let's say, and to reduce the heating of the camera itself.
Thank you, Paulo. Not all cameras do support binning. That's also a good reason.
Yeah, this is true as well.
Okay, I browsed the questions. maybe a question more for me. No? Will the COF 100, the 100G frame grabber be at almost same price as the COF 40 frame grabber? Then I can say that unfortunately, no. This is not possible. We need a much bigger FPGA, or I say much more powerful FPGA, not just due to the speed of the CoaXPress interface, but also the speed of the PCI Express bus. So we have not published the price of the Coaxlink QSFP28 yet. This will come very soon, but it's more expensive than the Coaxlink QSFP Plus. Next question, will it be possible in the future to select or add more FPGA memory on future versions? Maybe I also reply from this one, because that's something we have in our, I would say, almost to-do list. So it's possible. I mean, for some of the frame grabbers that support CustomLogic, we have access to FPGAs that would share the same footprint. So it would not be too difficult for us to generate frame grabbers with FPGAs from the same series, but with more memory or more capabilities. So if that's something that you are interested in, please contact us, and then we can certainly talk about it. Do you agree, Paulo?
Yeah, sure.
Okay. Another question, are QSFP28 cameras available?
So we are working with several camera makers for the moment. We can confirm that there are a number of QSFP28 cameras being developed right now. We have ongoing evaluations on the customer side with their applications using our frame grabber, our QSFP28 frame grabber, and some of these new cameras that will be released, I hope, very soon. I cannot tell more details about these cameras because we have to wait for the camera makers to release and announce these new cameras. But I can confirm that there are a number of cameras being developed in development right now. And one important thing is that 100G CoaXPress-over-Fiber, it's a quite new technology. So it's now that we are creating products using this new interface.
Okay, thank you. Unless I'm wrong, I don't see more questions. Let's go to maybe announcement of some upcoming events. So if you have more questions while I talk, go ahead. Quickly, so next week we will have a booth at the Yokohama Image Sensing Show. If you are in Japan next week, please let's meet and hold the booth number 14. Antonio Fan, our country sales manager in China, will give a presentation at the Vision China Beijing show that's on June 19th and 20th. And the title of the presentation is GigaVision 3.0. So if you are in China at that time, you are welcome. We'll also have a booth at the FPGA conference that at the very beginning of July in Munich in Germany. And then last but not least, the next Vision Talk will take place on July 10th. That's a Thursday. We will talk about OpenEVision and more particularly this month's release, OpenEVision 25.06. You can read the agenda, a sneak peek of the agenda there already, so you have an idea of what we are going to talk about and what will be available in that release of OpenEVision. There's also a QR code that you can use to register for this forthcoming Vision Talk. I don't see more questions. You agree, Paulo? Because sometimes I don't see all the questions. Last time I missed one. You agree, Paulo? No more questions from your side. So I think that we can conclude that meeting. As usual, do not forget to follow us on social media in order to stay informed about our latest news and other events. Thank you very much for your time. Thank you, Paulo, for your insightful remarks. Thank you, Sandrine, for organizing the presentation. And thank you to all of you for your time today. See you next time. Bye-bye.
See you. Bye.